Hello, welcome to JAcademy. In this video, I will show you how to delete any node from any specified location of a DLL. Okay, let us consider two scenarios. The first scenario will be the head is pointing to null and there is no node in the linked list. And the second scenario where you have more than one node and given a location, how you can delete that node from that location. So if we are going to have a pointer to the first node which will be called as temp1, and we are going to check out if in the first case if temp1 is equal to null, then the list is empty. Okay, so we are going to write if temp1 equals null. Okay, then we need to print list is empty else we need to do certain things. When you have more than one node, we need to take two reference pointer of the type struct node. The first one should point to the location where head is pointing to. That means, in other words, it will point to the first node. And then we need to, suppose the position is 3, we want to delete this node. Then you need to move this temp1 to the second node. Okay, this is same logic that we have used inserting any node at any specified location. Okay, so you have a for loop for I equal to 1, I is less than pos minus 1, I plus plus. Same loop we are going to use in this case as well. So here we are going to move my temp1 to the location one node before the node we want to delete, that is my second node. And once we do this, we will take one more pointer of the type struct node and will point to the node that we want to delete, and we call it temp2. Okay, and this will be called temp2. Okay, now using temp2 I have to do certain things. See, if I free this space, then the address stored for node 2, that is this link, will be removed, right? And the address stored for the fourth node, that means this link, will be removed if you free this. But the problem is that your fourth node's left link will point to the third node, as well as your second node's right link will point to the third node. So you need to do one thing. We have to connect this address to second node with the fourth node, and the fourth node should connect to the second node, and hence you will form a linked list of 10, 20 and then 40. Okay, so you have to connect this as well as with this. Okay, so temp2 has a big role to make this connection, right? So what we are going to do, we are going to tell that temp2's left links right link. Which is the left link? This is the left link. Right link is this location, is equal to, it will be equal to temp1's right link. Okay, is equal to temp2's right link. So what is temp2's right link? Temp2's right link is this one. It is having the address of the fourth node. So in other words, we are telling that this address should have, this right link should have the address of the fourth node. Okay, so let us write that part. So what we are doing is that we are running a loop, right? So for I equal to 1, I is less than pos minus 1, I plus plus, and then we are updating the temp1, so the temp1 will point to the its right link. So once it is done, temp1 is at this place, we will declare temp2. So temp2 is equal to temp1's right link. Okay, so now this temp2 has a major role to play. So we are going to say that temp2's right links, which is here, left link is equal to temp2's right link. Okay, so temp2's right link, that is equal to temp1's right link. Yeah, this one. So he is going to have the address of this one, right? So I'm going to say temp2's, this is right link, this is left link for the fourth node, left link, that means we want to update the value here of whose value, of the value of the second node is equal to temp2's, or we can say temp1's, temp1's right link. Next, so this is done. Next, we have to work with this address. So we will say that temp2's right link and its left link. Okay, so I am going to say, so temp2's left link is done. Okay, now we have to work with temp2's left link, right? Left link is pointing here and its right link. So we are going to write temp2's left link and its right link is equal to, now this guy got the address of this guy, so the fourth node has the address of the second node, and we want the second node to have the address of the fourth node. So we are telling that temp2's left link's right link, okay, so this is the right link for that, is equal to, now that you have to tell me, yes, it is equal to, come on, tell me, it will equal to temp2's right link, yes, so that is equal to temp2's right link, because here you can see that temp2's right link is what? It is the address of the fourth node. So this guy gets the address of the fourth node and this guy gets the address of the second node. So once they have each other's address, they can, this link is removed. But now the link only from the node 3 is pointing to both of them, that can be removed by just freeing the location pointed by temp2. I hope this is clear to all of you. So let us write this entire code together. So first of all, we have to write the function as void delete any location, and we are taking the positions when this function is called. And then we have to take two of the pointers, temp1 and temp2, and once it is done, we are going to point temp1 to head. Okay, next we have to do is that if temp1 is equal to null when there is no node, printf list is empty, deletion is not possible. Okay, and else what you need to do else you have to move this, right? So we are going to write for, I have not declared I, so I'll declare it here I equal to 1, I less than cos minus 1, I plus plus, and then we have to update temp1. So temp1 equals temp1's right link. Okay, so that's pretty cool. And then once we go, we have to now say that temp2 is equal to temp2 is equal to temp1's right link, right? So now we will write temp2 equal to temp1's right link. So that's done. Now we have to just do one thing. We have to have the address of node 2 should have the address of node 4, and node 4 should have the address of node 2. So we are going to write like this. Okay, it's done, and we are going to copy this, and there you go. So the entire thing is done for me. So this is the closure for else, and this will be the closure for the function. So that's how we can delete any node from any specified positions in a DLL. Okay, thanks for watching this video, and do like and subscribe my channel and share this video.